Welcome back. This is the second lesson recording for week 5 of distance learning for IM2. So circles. What do we know about circles so far? Well, we know the relationship between area, circumference, and radius and diameter. We also know the relationship between central angle, sector area, arc length, and inscribed angles. So for example, if we have this little sector with a central angle of 60 degrees, that will be our inscribed angle. And we know the relationship between the central angle and inscribed angle is that inscribed angle measure is half the angle measure of inscribed angle, and also half the angle measure of the arc. So inscribed angle, sector, radius, area, central angle, and arc, they are all very much related. To calculate one, you need the other information. Okay, so now up to now we've been looking at circles in terms of geometry. Okay, but we want to look in terms of algebra. Say if we bring that circle into coordinate plane, now we're looking for an equation of this circle. So then how can I get information such as radius or center of point if we put that on the coordinate plane? What is the relationship of all the points on the circle? To explore these questions, we are going to be watching a video called from Mesh Up. The link is there, and I showed you this video to the class. So if you're watching this, I have also put this link as part of the resource, so you can click on that to watch it again. So I suggest you pause the video right now and watch this video, which is about 7 minutes long. Okay, so assuming you've already watched the video, let's quickly summarize what we've learned. The equation of a circle. The equation of a circle in graphic form or standard form can be described in terms of x minus h all squared plus y minus k all squared plus r squared, where h and k is the center point. It's the point coordinate of the center of the circle, and r is the radius. So if you were trying to write the equation of this circle, and we are told that x minus h all squared plus y minus k all squared plus r squared, this is the standard form of circle, where h and k are the coordinate of the center and r is the radius. We can identify the center and radius and figure out what the center is. Okay, so how do we do that? We draw a line of symmetry horizontally and vertically, and where it crosses will be the center. Okay, so and then the center will be negative 3, 1, and radius is how far from the center to the circle. So we count these units, and in this case we have 4 units, so it's going to be 4. And then we substitute these values that we found into the equation template. So h is negative 3 and k is 1 and radius is 4. So substituting into the equation, it becomes x minus 3 all squared plus y minus 1 all squared plus 4 squared. And then simplifying this equation becomes x plus 3 all squared plus y minus 1 all squared is equal to 16. Okay, this time it's your turn to try, and I'm going to project the practice problem for you here. So here we go. You have 4 problems. You are given these graphs, and you are to write the equation of the circle for each of the graphs. So please pause the video and try to solve these problems. The answer will be shown in 3, 2, 1 seconds. Okay, so looking at this first graph, what is my center I draw the line of symmetry here, which identifies my center as 4, 3. So again, the x-coordinate is always first, and the y-coordinate is second. Right, then from there, I can figure out what is the radius. 1, 2, 3. So radius is 3. And therefore the equation of this line is x minus 4 all squared plus y minus 3 all squared is equal to r squared, which is 3 squared. And do I need to simplify anything? No, I just need to simplify the 3 squared as a 9. So the equation becomes x minus 4 all squared plus y minus 3 all squared, which is equal to 9. Okay. All right, next problem. Where is the center? Center is negative 4, 1 this time. Okay, so then, and r is, in this case, this is also 3. So 3 units to the right. So the equation becomes x minus 4 this time, all squared. I'm going to put that in parentheses so that I do not lose my negatives, plus y minus 1 all squared is equal to 3 squared. Now, x minus 1 simplifies to x plus 4 all squared plus y minus 1 all squared, which is equal to 9. And I have my equation. All right, then the third problem. Where is my center? Oh, it gets a little bit tricky because the center is on the x-axis. So what's the x-coordinate? X-coordinate is 1, y-coordinate is 0. So it just means that h is 1 and k is 0. Radius in this case is 1, 2, 3, 4 units. So the equation becomes x minus 1 all squared plus y minus 0 all squared, which is equal to 4 squared. And so x minus 1 all squared you cannot do anything about. What about y minus 0? What's y minus 0? It's just y. So it just becomes y squared is equal to, what's 4 squared? 16. And that's my equation of that line. Oh, not line, circle. And finally, the fourth problem, center is, in this case, made really simple, 0, 0. That means h is 0 and k is 0. Radius in this case is 1, 2, 3, 4, 5. So the equation is really simple. X minus 0 all squared plus y minus 0 all squared, which is equal to 5 squared. And x minus 0 is just x 0. So it becomes x squared plus y squared is 25. Okay, so when the center is at the origin, that's the simplest form of a circle with the given radius being the square root of the constant. Okay, I am going to give you 4 more problems. This time, you need to identify the center and radius of each of these equations. Okay, so this is an equation of a circle. How do we know? Because the x is being squared, y is being squared, and then there is a constant. Okay, so next year in IM3 you're going to come across more complicated conics equations, somewhat different but somewhat similar in this form as well. So this is an equation of a circle. And what is going to be the center? Well, there is no h term, which means h is equal to 0. So 0 is my h term, and y minus 0, this is same as y minus 0, so k is also 0. So center is 0, 0, or the origin, and the radius is square root of this constant, which is 9. What about this? Again, center is 0, 0, and radius in this case is square root of 50. Now what is square root of 50? Can we simplify this any further? Well, we can simplify this as square root of 25 multiplied by square root of 2. Why did I choose square root of 25, not some other numbers like 10 and 5? Because 25 is a perfect square. Square root of 25 simplifies to just 5. And we are left with square root of 2. So it's 5 root 2. So the radius is 5 root 2. Okay, lastly. Okay, what is my center? From here, I know that this negative sign is part of my equation. Okay, so that means h is just 5. Okay, but we also need a negative sign here as well, don't we? Okay, so we need to convert this into negative, or we need to take a negative of this 13. So we could have converted this as y minus 13 all squared, in which case we can clearly see that k is going to be negative 13. And then r is going to be square root of 16, which is going to be 4. So the center is 5, negative 13, and r is 4, and that will be my answer. And finally, looking at this, this is my h value, this is my k value, because I already have this negative and negative, so I do not need to do anything to it. So simply center is 5, 12. It's without the negative sign because negative sign belongs to the standard formula. The radius is square root of 40. Okay, square root of 40. Can we simplify this any further? Is 40 a factor of a perfect square? Yes, it's 4 times 10. And what is square root of 4? It's 2. And then we still have square root of 10. So r is 2 root 10 and c is 5, 12. Okay, let's go backwards this time. If we were given the equation, now that we know how to figure out the center and the radius, can we graph it? Okay, well, this is a template for our equation of circle, so we can rewrite the equation if we need to. This is I've done here. So instead of writing x plus 2, I can write it with as x minus 2, because we have this negative sign here, and that's really important. And we have this negative sign right here as well. So it's y minus whatever the k constant is. Okay, and then the radius. So then identify the center and radius. So the center is negative 2, 1, and radius is 6. So from here, I mark my center, and then go 6 units in all direction, mark my 4 points, and then finally draw my circle. Okay, simple as that. Okay, this is your turn. I'm giving you 3 problems, 3 equations of a circle, and I'm going to ask you to graph it. So please pause the video and try it yourself. I will quickly demonstrate the first one again. I figured out the center to be 1, negative 3. Reversing the sign for the y value here because this is positive, not negative, and r is 4. So I mark my center, and then I go up 4 units from the center, 4 to the right, 4 below, and 4 to the left. And after I've marked them, I draw, connect, and try to connect my points to draw a nice circle. I didn't do so well here. Okay, all right. So same idea with the other problems, and I'll show you your answer. Okay, here are the answers. Center is 0, 2, and r is 5. The last question was a little bit tricky because square root of 5 is not it's not an integer, but it's 2.23. But you do the same thing. You find your center and go 2.2, about a little over 2 units up in all directions and mark it and then connect it. Okay, that's it for now.